Good afternoon. So today I'm about to present about solid state assignment 2, question 2. So this is regarding Pauli exclusion principle. So it is the electronic structure of the atoms and the formation of energy bands. That's what it explains. So in an isolated carbon atom, it ensures that no two electrons occupy the same quantum state. When carbon atoms bond to form solids, this principle results in the formation of energy bands. So the next would be this is the figure shown in the question. So I'm supposed to explain what is observed and discuss about it. So based on the formation energy band for isolated carbon atom shown in figure 2, there are few observations and discussions. So there's a total of five observation discussions I'm about to discuss. One is atomic energy levels, formation of molecular orbitals, valence band formation, conduction band formations, and band gap. So the first would be atomic energy levels. So in an isolated carbon atom, the discrete energy levels correspond to the electron configuration in the 1s, 2s, and 2p orbitals. The Pauli exclusion principle states that no two electrons can have the same set of quantum numbers. For carbon, this means that 1s orbital is filled with two electrons and the 2s orbit and 2p orbitals hold the remaining electrons. For carbon, the 2s and 2p orbitals have distinct energy levels, and the electrons fills these orbitals in accordance with their quantum numbers. So the next would be the formation of molecular orbitals. When carbon atoms bond to form molecules, the atomic orbitals overlap to form molecular orbitals. The overlap of atomic orbitals result in splitting of energy levels into set of closely spaced levels that form the energy bands in a solid. For carbon, sp3 hybridization leads to the formation of bonding and antibonding orbitals. The next would be valence band formation. The energy levels of the filled 2s and 2p orbitals in a carbon atom merge to form the valence band in a solid. In a solid, the discrete energy levels of the 2s and 2p orbitals combine to form a continuous band of energy levels. The Pauli exclusion principles ensure that each energy level in this band is filled according to the number of electrons and spin restrictions. This band is occupied by electrons that are involved in bonding. So next would be conduction band formation. It's above the valence band. There is a conduction band where electrons can move freely and contribute to electric conductivity. The conduction band forms the higher energy molecular orbitals that are unfilled in the carbon lattice. The Pauli exclusion principle still applies, as electrons filling the conduction band must obey the exclusion rule and cannot occupy the same quantum state as another electron. As explained, electrons can jump from valence band to the conduction band if enough energy is provided. Then the next would be the band gap. So the energy gap between the valence band and the conduction band is known as the band gap. The band gap represents the energy difference that electrons must overcome to transition from valence band to the conduction band. The Pauli exclusion principle ensures that this band gap exists because it creates a gap in energy levels that cannot be occupied by electrons, maintaining the distinction separation between filled and empty states. And that would be all. Thank you so much.